Good day everyone, trust your day is good. Today we are moving to a new topic entirely, which is mathematical induction. Okay, so mathematical induction is just the what mathematical statement you use to prove. Okay, so there are some rules that you have to follow if you want to prove out that something is equal to or something is true. Okay, now let me give you the rules that guides this topic. Okay, now let's say p of x is a what mathematical statement and is defined for all natural numbers, let's say n. Then we can say p of x is true if number one, p of 1 is true. 2, p of k is also true for some n is equal to k. Then the third one and the last one, but not the least, is p of k plus 1 is also true. Then if that statement satisfy the three rules here, the three conditions, then you can now go on to say that it is what defined and it is true for all natural numbers. Do you understand? So make sure you pay attention to how I'm going to be proving them out, as it will really help you to say something is true or not true, like to make decision. Do you understand? Okay, now we have the first question to be, okay, they ask us to prove that for all natural numbers all the following are true. Okay, how will you do that? Okay, let's check on let's first check the first question there. Okay, so this is the first question. They ask us to prove it out that it is true for all natural numbers. Okay, how are we going to do it? Don't forget the three steps. First, find p of 1, p of k, and p of k plus 1. How will you do that? This one is our left hand side, that is a variable, and this one is our right hand side. Okay, so it means that for this p of 1, it means p of this one of this must be equal to p of, that is the left hand side must be equal to the right hand side. Okay, so we have our left hand side to be n, so and p of 1 when n is equal to 1. Okay, let me write it. When n is equal to 1, so this one will be 1. Your right hand side too, you have that 1 over 2 into 1 plus 1, so 2 can cancel 2, you have 1. So you can now say L left hand side is equal to right hand side, and that means that p of 1 is true. You understand? Now move on to the second one. For n is equal to k, so it means that you have that 1 plus 2 plus 3 plus, make sure you are following the step on how I'm doing it. That's how you will be doing it. Do you understand? Plus k is equal to 1 over 2k into k plus 1. Do you understand? Okay, now for some, you don't need any calculation here. Oh yeah, go further now. For k plus 1, you have that 1 plus 2 plus 3 plus k plus 1. You understand? So, and don't forget that this one you see is here, so it can be represented by what? You can represent it by this. So it means that you have 1 over 2k into k plus 1 plus k plus 1. You understand? So this is it now. And how will you prove that it is true? It means that if I should solve this one finish, I should simplify it finish, I should be able to get something like, if I input k plus 1 here, that is 1 over 2 into k plus 1 into k plus 2. If I input k plus 1, so this one must be equal to this one. So that's when you can say that it is true for all natural numbers. Do you understand? Now let me simplify this one further. We have 1 over 2, right, into k squared plus k, right, plus k plus 1, so which is equal to 1 over 2, right, 1 over 2 k squared plus 2k plus 1. So you can simplify this one by saying it is what, 1 over 2 into what, okay, k, I'm coming, let's go back here. We have that plus what, k plus 1. Okay, that's correct. Okay, let's look at it from this perspective. Okay, now from here, now I can find the LCM, right? So I can say that which is now equal to 2, right, into k squared plus k plus 2 into k plus 1, because this k plus 1 and it doesn't have any fraction, so you find the what, LCM. So you now have that k squared plus k plus 2k plus 1, everything over what, 2. And I can factorize this one, right, to get what, k plus 1, k plus 2. You understand? I'm coming. This one should be 2k plus 2. Okay, so everything over 2. So do you understand now? So k plus 1, k plus 2, everything over what, 2. So it means that this one is equal to this one. So you can now say that this one, like this question, it is true for all natural numbers. That's when you make a what, conclusion. Do you understand? Okay, let's look at this second one. You will also follow the same step as we did in example 1. Do you understand? So you test for when n is equal to 1. So this is your left hand side and this is your right hand side. So left hand side is equal to what, 2 into 1 minus 1, everything all squared, and that one will give you 1. And for this right hand side too, you have 1 over 3 into 1, or 4 into 1 minus 1. So this one will be 3. 3 will cancel 3, so it is the same thing as what, 1. So you can now see that the left hand side is equal to right hand side, which means p of 1 is what, true. So after testing that one, you go further by saying for when n is equal to some k. Do you understand? So you have that 1 squared, do you understand, plus 3 squared plus 5 squared plus, when n is equal to some k, you put k, 2k minus 1, everything else squared, is equal to 1 over 3k into 4k squared minus what, 1. You understand? Now you go further by testing for what, when n is equal to k plus 1. For n is equal to k plus 1, you are using the second assumption. Do you understand? So you have 1 squared, which is equal to 1 squared plus 3 squared plus 5 squared plus you put this one, 2k minus 1 all squared, plus when n is equal to what, k plus 1, you put k plus 1 here. You are not testing for this one, you won't touch this one now, put k plus 1 here. So you know this one is for when n is equal to k. So for n is equal to k plus 1 now, 2 into k plus 1 minus 1, everything all squared, right? So we have that. And don't forget that this one can be represented by what, 1 over 3, because we say it is equal. So you can now say everything here is 1 over 3 k into 4k squared minus 1 plus this one now, 2k plus 2 minus 1, that's 2k plus 1, everything all squared. You understand? Okay, now I can what, expand the brackets. We have 1 over 3, right, into 4k cubed minus what, k, plus 4k squared plus 4k plus what, 1. You understand? Okay, now I've expanded what, brackets now. So you can go further by saying that, let me make this 3 the LCM. So we have 4k cubed minus k, okay, plus minus k plus 12k squared plus 12k plus 3. Okay, now simplifying further, we have that 4k cubed plus 12k squared my plus 11k plus 3 everything over 3. So this one can be factorized. Do you understand? You can leave it like this, or how will you know that this one is correct? Or you can factorize. Okay, let me factorize k plus 1 out. So how will you get that one? So if you factorize k plus 1, you have k plus 1 into, you have that one will be 4k squared plus 8k plus 3. Okay, yes, divided by what? Everything divided by 3. You understand? And this one can also, I can also simplify this one by saying that we have k plus 1 already. I can say that here I can factorize my 4 out and put k plus 1 all squared minus 1. If you simplify, you will see that this one will be the same thing as you putting k plus 1 into this one. So you see that this one, when you put k plus 1, is the same thing as this, what you get when you use the word second assumption. So that means that the left hand side is equal to the what, right hand side. So p of k plus 1 is true for all natural what numbers. Those, so that's how to what do that one too. So let's move on to the third one. Okay, don't forget to subscribe to the channel, like this video, comment and share to your fellow classmates. Okay, so we have the third one, 1 over 1 of 3. Okay, so this is the third question. How will you prove this one out? Okay, now you still follow the same step. So for n is equal to 1, you have that this side must be equal to this side. So you have 1 over 2 into 1, which is 2 minus 1, that's 2, and this one will be 3. So 1 of what? 3. This is your what? Left hand side, and your right hand side should be what? When n is equal to 1, you have 1 over, right? Substituting 1 here, that one will also be what? 3. So the left hand side is equal to right hand side, and that tells us that p of 1 is true. So move on to the next one. For n is equal to some k, you simplify. You have 1 of 3 plus 1 over 3 of 5 plus 1 over 7 of 5 plus, when n is equal to some k, you have 2k minus 1. 2k plus 1 is equal to k over 2k plus 1, right? So that one is for when n is equal to k. For n is equal to k plus 1, you use the word second assumption. Don't forget, you have 1 over 1 of 3 plus 1 over 3 of 5 plus 1 over 7 of 5. Okay, plus, you still add this one, plus 1 over 2k minus 1, 2k plus 1, plus, when n is equal to k plus 1, now simplify. So if you put 2 into k plus 1 minus 1, so you have 2k plus 2 minus 1, which is 2k plus 1. Okay, for this one to 2k plus 1, that's 2k plus 3. You understand? So now you now want to what? Okay, it's not yet done. You can see that this one can be represented by what? By k over 2k plus 1. So you say k over 2k plus 1 plus 1 over 2k plus 1, 2k plus 3. Now what you want to do is that you want to solve this one and show that if you simplify this one, what you get will be the same thing as when you input your k plus 1 into the right hand side of the what question. Do you understand what I'm saying? Okay, now let's go. So now what can you do here? You can find your LCM. 2k plus 1, 2k plus 3, right? So finding your LCM, you have that k into 2k plus 3, right, plus what? 1. Hope is cleared. Okay, so simplifying for that, we have that 2k squared plus 3k plus 1, everything over 2k plus 1, 2k plus 3. Using factorization method to factorize the what? The numerator, you get what? So what do you have? You have that is equal to 2k plus 1, okay, into k plus 1 over 2k plus 1, 2k plus 3. You you can now see that this one will cancel out. We have what? K plus 1 over 2k plus 3. Now this is your final answer. You now go back to the question. Here what they give us, the question, you know that in your final solution you get k plus 1 over 2k plus 3. Now test for k plus 1. Here you will see that you will have the same thing. This one will be k plus 1 over 2k. 2 into k plus 1 plus 1 will give you 2k plus 3. That means the left hand side is equal to the right hand side, and that makes this statement to be what? True for all natural numbers. Though that's that for that one too. Now let's move further to another question. So this one is telling us, this is another question entirely, okay, and this one is telling us that is 24 an integer, is this one an integer multiple of 24? How will you do that one? You follow the same steps, though there are something that's changed there. Okay, now test for when n is equal to 1. You have that, which is equal to what? 5 raised to power 2 if you substitute 1 minus 1, which is what? 24. But this 24 can further be simplified by saying that it is equal to 24 multiplied by 1. So this one is a what? Natural number, right? You can use it to represent any letter, which is 24m. Let's say we have 24 what? M, right? Now, so you know that after testing for when n is equal to 1, you continue by saying for n is equal to k. So you have 5 raised to power 2k minus 1, because you will substitute it to the what? To the question that they give you. Do you understand? Now, you know they say n is what? Like if this one is an integer multiple of 24, you understand? So it means it must be equal to this one, 24m. So you can try to make 5 raised to power 2k the subject of the relation, which is what? 24m plus 1. Now you continue further by saying for n is equal to what? K plus 1. So you have that using this one, 5 raised to power 2n minus 1. So it is 5 raised to power 2k plus what? 2 minus 1. Right, according to law of indices, you can split this one by saying 5 raised to power 2 into 5 raised to power 2k minus 1. But remember that 5 raised to power 2k is 24m plus 1, so it means 25 into what? 24m plus 1 minus 1. So you have that 600m plus 25 minus 1, which is what? 600m plus what? 24. So what's the next step? You must look like, since it's an integer multiple, you must be able to factorize 24 out for it to be true. So let me factorize 24. I have that it's equal to what? 25m plus 1. Therefore this one is true, that is this 5 raised to power 2n minus 1 is an integer multiple for 24. So that's that for this question. That's how to do this kind of question. Okay, now let's move on to another question entirely. Now let's check out this type of question too. You still remember the procedure we have to follow. For n is equal to 1, it means the left hand side, which is n raised to power 3, is equal to 1 cube, which is 1, right? And the right hand side, this one, 1 squared into 2 squared over, because 1 plus 1 will be 2, 2 squared over 4. So you have that 4 cancel 4, you have 1. So we can say the left hand side is equal to the what? Right hand side. So which means the what? P of 1 is what? True. Since P of 1 is true, you can move on to the next one. For n is equal to some k, you substitute 1 raised to power 3 plus 2 cube plus 3 cube plus k cube is equal to k squared into k plus 1, everything else squared, over 4. So now you leave this one, you continue further. For n is equal to k plus 1, but you will be using the word second assumption, which is for n is equal to k. Okay, now we have 1 cube plus 2 cube plus 3 cube plus k cube. Now you will include k plus 1 now using the what? The function here. So you have k plus 1, everything is to power 3 is equal to, okay, now since you know that everything will now be equal to, since you know that from here to this k cube, can be represented by what? This one. So you can input that k squared into what? K squared, because this everything here is here, so, and they say this one is equal to this, so k squared plus k plus 1 all squared over 4, plus you add it to this one, And don't forget how we do it. Like, we want to make sure that after simplifying we will be able to get the same value as substituting k plus 1 directly here. Do you understand? So that's that for that. Now let's continue. Now here it will require a long way for us to be opening the bracket, right? So let's do like this. I'm coming. Okay, now we can find the SCM, right? Okay, finding the SCM, I have that k squared into k plus 1 everything all squared plus k plus 1 or 4 into k plus 1 or q. So simplifying, for I can factorize k plus 1 square out, all squared into k squared plus, right? So it will remain what, 4 into k plus 1 a, right? Everything over what, 4. Now let's continue. So we have that, simplifying from where we stop, we have k plus 1 all squared into k squared plus 4 into k plus 1 everything over 4. So you have that k plus 1 all squared, right, into k squared plus 4k plus 4, right, everything over what, 4. This one you can simplify it, right? I'm coming. You have k squared, okay, plus 4k plus 4, so you can simplify. Now you will get, after simplifying, you get that you can factorize this one, so you will get k plus 2 twice everything over 4. So you can now say that it is equal, because if you substitute k plus 1 here directly, you will get the same thing as what, following the what hypothesis to get it. So you can now say that p of k plus 1 is true for all natural numbers. Do you understand? So that's how to make what, conclusion. Okay, now let's move on to the what, I think that's the last question for today. Okay, so this question 6, 9 is a factor we are asked to prove. Still follow the same step. For when n is equal to 1, you have that 5 raised to power 2, substituting 1 plus 3 into 1, which is 3 minus 1, is equal to what, 25 plus 2 is 28 minus 1, that's 27. Okay, so but this 27 can be simplified by saying it is equal to 9, because you can factorize this 9 from this 27, multiply by what, 3, because 9 is a multiple of 27. So from apart from this, now you can say this one is a natural number, right? So it is what, 9 multiplied by, let m represent the natural number, or n, or something that you like. Do you understand now? So now for when n is equal to k, you get that okay, you have, substituting here, 5 raised to power 2k plus 3k minus 1, right? So now you continue, no, and because it is what, is a factor, so this one will be equal to this one, 9m. That is for when n is equal to k, this one will be equal to the what, for when n is equal to 1. Do you understand? So for when n is equal to k plus 1, now you have that 5 into 2k plus 2, substituting here, this is what I'm using, plus 3 into k plus 1 minus 1, so which will give us what, 5 raised to power 2, using law of indices to split the what, the 2, plus 3k plus 3 minus 1. Simplifying further, we have 5 square into 5 raised to power 2k, right, plus 3k plus 2. Now 5 raised to power 2k, okay, we have to make it a subject of the formula here. 2k is equal to 9m minus 3k plus 1, right? So you have that 5 square into what, 9m minus 3k plus 1 plus 3k plus 2, so which is equal to what, 25 multiplied by 9m, that one will give us what, 25 multiplied by 9m, so we have 225m, right, minus 75k, okay, because 25 multiplied by 3, that's 75, right, plus 25 plus 3k plus 2. Simplifying, 225m, right, This one and this one will give us minus 72k plus 27. Now this is not the end of the solution. You have to make sure that you factorize 9 from the last expression that you get, and if you can factorize 9 out and it can go 0, it means that it's a factor. Now factorizing 9, it will remain what from here, that will be 25m minus, if you factorize 9 from 72, and that one will give you 8k. Factorizing 9 from 27 plus 3. So since 9 can be factorized, it means that 9, therefore, okay, you put since all the 3 condition are satisfied, therefore 9 is a factor of 5 raised to the power 2n plus 3n minus 1. So that's that for mathematical induction. That's all you have to know. If you go and check everything, where you should be able to understand this concept. Thanks for watching. Make sure you go to the channel, subscribe, like, comment and share to your fellow friends, and make sure you turn on your notifications so that whenever I drop another video, you will be notified. Thank you for watching. Have a nice day. Goodbye.